Hello everyone. So in this session we will discuss about Python. Okay, I'm Bhavya from JNtech Networks. So in this session we will discuss about Python, like what is Python, okay, features of Python, Python 2 versus Python 3, where we can use Python, who can learn Python, softwares, okay, Python basics versus Python advanced, and we will discuss the course content of Python. Then we will discuss the projects, okay, and the installation process. So let's write the agenda first. Okay, so we will see what is Python. Then features of Python. Then Python 2 versus 3. Okay, like we have two versions of Python, Python 2 and 3. So we'll see what is the difference in Python 2 as well as in Python 3. Then where we can use Python. Okay, then we will see the softwares. Okay, we will use in the upcoming or in the entire sessions. Then we will discuss Python basics versus advanced. Then course content of basics Python and advanced Python. Okay, then projects. We will see like the list of projects. Okay, the installation process. Then we see first code. Okay, then we will start. This is all about intro part of Python. Okay, like introduction. More as we will discuss about history of Python. Okay, so this is the introduction part. Second part, we will discuss about variables, naming conventions, data types, okay, mutable versus immutable data types, then typecasting, comments, indentation, okay. So variables, naming conventions, data types, mutable versus immutable, typecasting, comments, indentation, and more else, tokens, keywords. Okay, so these are like Python fundamentals. Okay, and first we will discuss about introduction. Okay, that is introduction part. Second, we will discuss about Python fundamentals. Then we will discuss about, okay, so let's see. We will discuss about Python operators. Okay, so basically we have various types of operators. We have assignment operators, arithmetic operators, comparison operators, bitwise operators, membership operators, logical operators. So we will discuss that one by one. Okay, then we will see Python operators and then we will see the control flows that are on inside control flows. They are like conditionals as well as conditional statements, which means we have if, elif, else. Then we will see loops, which is while loop and for loop. Okay, with statements like break and continue. So this is going to be the agenda for today and as well as for tomorrow. Okay, so this session is of 3 hours. Okay, so first we will discuss about introduction to Python with course content. Okay, then Python fundamentals, Python operators, okay, control flows and loops. So in Python operators, let me mention the operator's name, arithmetic operator. We will discuss assignment operators, membership operators, okay, logical operators, with wise operators, okay, and more else. Okay, comparison is left. Actually, we have to put it out. Okay, comparison operators. And mean more else identity operators. Okay, so we have 7 types of operators. We will discuss it one by one. So let's start from the very basics. That is, what is Python? Okay, so basically, what is Python? We can say that Python is a programming language. Okay, simple. So we will keep it simple. So Python is a programming language. Now, what is the means of programming here? So programming, basically, we can mention here why we need a programming language. So basically, we need programming languages to interact with the PCs or with the machines or with the computers, because machines can only understand binaries. Okay, binaries like zeros and ones. Forget it. Okay, so but machine can only understand binaries, and we cannot like code in binaries, because suppose you are coding any let's say A as an alphabet, so the binary is of like 8 bit. Okay, so this is just an example. So we cannot code in binaries. So to communicate with our PCs, or to give instructions to the PCs or to the machines, we have to use programming languages. So we can say that to communicate with the machines, or to give instructions to the machines. Okay. For this purpose, we need a programming language. Okay, because our programming is like like many types. We have high level, we have low level, and we have mid level. So we can mention here types of languages. So we have high level language, we have low level language, and we have let's say mid level. So high level means which is close to human language. Okay, so which is close to human language. For example, okay, so we have high level, low level, and mid level. So high level is like which is close to human language, which is like English. Low level is like which is close to machine language, that is binaries, in binaries. Mid level is like combination of high level or low level, like in middle. So for example, for the high level, we have Python. For the low level, we can see that we have assembly. Okay. And mid level, we can say that C or C++. C, we can say that, okay, in some scenarios. So we can say that. So high level is like which is close to human language, means the code of the high level language, let's say Python. So the code or the syntax of the high level language is in the favor of human language, which it means is in English. For example, if you let's write a function in Python print. Let's say hello world. Okay, so we are printing. So you can see print is a English word. Okay, you can see print is a statement. Even a non-technical person can understand that print is a statement or it is a function which is used to print something or which is used to display something. And what is going to display that is hello world. Okay, so anyone like any non-technical person or any beginner can easily understand the Python language because it is a high-level language, which means it is coded in English. Okay, so all like most of the part of Python is in English. So we can say that Python is a high-level language, which is close to human language, which is English. Low level is like we have assembly language, okay, which is like a combination of signs, binaries, etc., symbols, okay, which is hard to code. Okay, so which is binaries. So we can say that Python is a high-level language. So why we need a programming language to communicate with the machines or to give instructions to the machines because machine can only understand binaries. Okay. So now here we have a compiler or we can say that we have an interpreter which converts your your programming language, your English code to a binary languages. Okay, that is a part of another way. Okay, we will discuss that. Okay, so in simple, we need a programming language to communicate with the machines. So let's discuss. And Python is a programming language. Okay, so let's discuss feature of Python. So first, Python is a high-level language, which means Python is easy to understand, and Python is easy to learn. Why it is easy to understand? Because it is a high-level language. High level means it is close to human language, which is English. That is why we can say that Python is easy to understand and easy to learn. Okay, because of its high level nature. Then we have Python is interpreted programming language. So what is the means of interpreted here? See, let's take an example of C or C++. Okay, let's take a C example. Suppose there's a C language. Okay, so suppose there's a C language code. So in the C language, first you have to code, then you have to compile it, then you have to run it. So this is a process in the C. Okay, suppose first you have to code your whatever you are coding. So you have to code it, then you have to compile it, and then you have to run it. So in this, suppose there's a extension of C that is .c. So you are compiling it and you are making it you are compiling and you are making it .exe file. Then only you can run it. Okay, so there's a three-way process in the C language. You have to code, you have to compile, and you have to run. So okay, like and if there's any error in the C code, so you have to make change first in the code, then again you have to compile it and then you have to run it. Okay, but in Python language, these are only two process that is code and just simply run. Okay, we have a .py file and then we are running and we have the output. So in the Python language, we are coding and we are running it. Simple. There's no compilation process in the Python. And why there's no compilation process? So see, in C, your compilation process is like your code is converting into binaries or into the language that a machine can understand. Okay, but in Python, your .py is like you can run it without the compilation process. Now, then who will convert your Python code to binaries or who will convert your Python code to the languages that machine can understand? That is your Python interpreter. Okay, that is why we can say that Python is an interpreted programming language because there's no compilation process in your Python language. You just need to code and then run, code, run. And if there's any error, make changes in your code, fix your error, and then run it. Okay, so there's no compilation process in Python and all your like converting your code into binaries or or the languages that machine can understand. This is all the process. We will hand over it to interpreter. Okay, Python interpreter. So that is why we can say that Python is an interpreted programming language. There is no compilation process in Python as we have in C or C++. Okay. So Python is a high level, easy to understand, easy to learn, and it is an interpreted programming language. Then Python is a dynamic in nature. Okay, so it is a dynamic programming language. So dynamic means, so let's take an example again of C or C++. Okay. Suppose there's a variable in C, let's say A. A is a variable and we have a value. So we are assigning 10 value, 10 is a value here and A is a variable here. So we are assigning 10 value to variable A. Okay, and there's a Python code, let's say. So in the Python language, there's a variable and we have a value. Okay, so we are assigning value 10 to variable A. So A is a variable here. Now what is a variable? Variable is a container which is used to contain your value or which is used to store your value. Okay, we will discuss in detail in like upcoming sessions. So we have a value and we have a variable. Now in the C language, we have to tell the variable like which type of value we are storing. Suppose 10 is a number. But in Python, but in languages, we have a like division of numbers. We have integers, we have float, and we have complex numbers. Okay, we have constant numbers also. So here we have to put int. It means integers. Okay, so we will discuss that. So here it is just an example. So int is an integer here. Okay, and a. So here we have to tell the Python C compiler that which type of variable we are storing inside a variable, like which type of value we are storing inside a variable. So we have to put int. Suppose we are storing any character, so we have to put char. Okay, or any character, let's say b or any z character. Okay, so here we are storing any a value in the form of character. So we have to tell a Python, a C compiler that which type of value we are storing inside this variable. So we are specifying we are storing character here, and this is my character. Okay. Now, but in Python language, we don't need to tell anyone, or we don't need to tell the Python interpreter that which type of value we are storing. Basically, we are storing integer here. So just we are making a variable here a and we are storing a value. That's it. Okay. So that is why we can say that Python is a dynamic in nature. Why dynamic? Because we can store any type of value, and we don't need to tell anyone that what type of value we are storing. Okay. So this is dynamic in nature. Then we have Python is a object oriented programming approach. Okay. That is known as OOPS concept. Okay. I think you might heard of it. So OOPS is like OOPS concept object oriented. So in the so Python follows a object-oriented programming approach, which means Python we have inside OOPS concept we have many concepts, like we have classes, we have objects, we have encapsulation, inheritance, polymorphism, abstraction, etc. So OOPS means we are binding the data or we are just reusing the data. So that is why we are using the classes and objects so that we can reuse the data or we can provide a structure format to a code. Okay, here we are providing a structure or a clean format to your code. Okay, because coding is not enough. How you code is very important. Okay, matters. So your code should be clean. Your code should be short. So that matters. Okay. So make sure to use the object-oriented programming approach in your coding. That is very important. So we have many concepts inside objects inside OOPS. We have encapsulation, like we have abstraction, inheritance. Okay, we have various types of inheritance. We have polymorphism, etc. So it is like we use OOPS to reuse the code as well as we use OOPS to structure your code in a proper format so that your code should be clean. Okay. Now here Whereas Python is a general purpose. Before that, Python is an open source. So what is the means of open source here is open source means open source means we can modify and read the source code of Python. Okay, like we can. Okay, so open source means we can read and we can modify the source code of Python. Second, we can contribute in the Python source code. Even means contribution means we are like just modifying or we are just adding something in the Python code. Okay, source code. That is like the Python official source code. So open source means we can read, we can modify the source code of Python. We can add something, we can modify, we can update some features, we can add some more libraries, etc. Okay, so Python is open source. Now, Python is general purpose. So basically, Python is a general purpose programming language, and Python has vast amount of libraries and frameworks. So general purpose means we can use Python everywhere. Like we can use Python in every domain. For example, we can use Python in cybersecurity. We can use Python in data science, in machine learning, in AI. Okay, in neural networks. Okay, we can use Python in deep learning. We can use Python in IoTs. We can use Python in web development, application development. We can use it in games. Okay, and we can use it in like networking, etc. So there are like various uses of Python, and we can use Python everywhere. Okay, because why we can use Python everywhere? Because Python is an open source. Okay, so we can use Python everywhere. So Python has vast amount of libraries and frameworks. Okay, and they like different libraries for different purposes. For example, we have Selenium. Selenium is a library for automation. We have pandas and numpy. They are used for the data cleaning and data and numpy is used for mathematical operations. Okay, and we have whereas we have matplotlib, cbon. They are used for data visualization. So we have we have vast amount of libraries, frameworks, packages in Python. Okay. So Python is a general purpose, means we can use it everywhere. Now where we can use it? We can use it in cybersecurity domain. Okay. So we can mention here domains. Cybersecurity domain, networking, automation, data science, machine learning, artificial intelligence. Okay. Neural networks. What is website development? Okay. We can use in application. Or else etc. IoT and ODs, etc. Like we have many uses of Python. Okay, so even we can mention one more, that is GUI. GUI. Okay, so we have many uses and we can use Python like in multiple domains. Okay, we can use in Python in cybersecurity and in cybersecurity to create malwares. viruses, or we just mention malwares or tools. Okay, like hacking tools, like information gathering tools, scanning tools, exploiting tools, etc. In networking, we can use we can use libraries like socket, request, etc. Okay, for creating your own like client and server, etc. Okay, like we can connect your client and server with the help of Python. Okay, we can send mails through Python. Okay, we can open any port number through Python. Okay, we can connect to any protocol with the help of Python. We can apply in automation. Okay, we can automate your stuff with the help of Python. Even we can automate your whole Python GUI. Okay, your own your OS GUI with the help of Python. Okay, we can automate your day-to-day stuffs like with the help of Selenium, web scraping, beautiful soup, etc. We can use data science. We can use Python in data science. Okay, in data cleaning. Okay, data analysis, data visualization. Okay, etc. Like we have in ML, we can use Python in data feeding. Okay, we have to feed your data to a ML algorithm. Okay, so that we can create a model out of it. Okay, so we have to create a we can feed your data. We can feed a data set to a model with the help of Python, etc. So we have like many uses for Python. That is why Python is in trend. Okay, and why Python is in trend? Because of these all features. It is a high level. It is a like easy to understand. It is a interpreted programming language, dynamic in nature, object oriented programming approach. Okay, it is an open source. It is a general purpose so that we can use in different domains. Okay, it is like it have vast amount of libraries and frameworks. So next we have history of Python. I suppose I should write here only. Okay. So we have history of Python. So Python is invented by Guido van Rossum in 1991 in CGI, Netherlands. Okay. So now Python name. Okay. So Python is invented by Guido van Rossum in 1991 in CGI, Netherlands. And Python names comes from a comedy show that is a comedy BBC comedy show that is Python's Flying Circus. Okay. Now Python is a the base language of Python is a ABC programming language. Okay. So we can say that Python is derived from the ABC language. Okay. Somehow we can set it. That is all about history of Python. Okay. Now we have Python. Basically, first we have Python 2 and then we have Python 3. Now, what is the difference in Python 2 and 3? So, Python 3 is a modification of updated version of Python 2. Okay, so it is an updated version of Python 2. So nowadays we only use Python 3. Like in most of the scenarios we use Python 3 only. Okay, so what is the difference in Python 2 and Python 3 now? So there's a syntax differences now. Okay, for example, uh, first we have print. Okay, so in Python 2 we write print hello world. Okay, without parentheses. But in Python 3 we write print. So first we write print. So in Python 2, we used to write print like without parentheses. But in Python 3, we write using parentheses, means using round braces. Okay, these are round brackets. Now, in Python 2, we write input, raw input. Okay, to take input from the user. But in Python 3, we write input only. In Python 2, we write X range. Okay. For using the range function. In Python 3, we write only range. Okay, like we have many syntax differences in Python 2 and Python 3. Okay. So basically, even there are like lots of libraries which are only compatible with Python 3, not with Python 2. Okay. So now the current version of Python is Python 3.11. Okay. So that is all about Python 2 versus 3. Now where we can use Python? So we can use Python in many domains. We can use in cybersecurity to create malwares or tools. We can use networking. We can use Python in networking for the automation. We can use in automation to automate your tools to automate your day-to-day activities. We can use Python in data science. Okay, for the data analysis, for the data cleaning, for the data exploratory. Okay, we can use Python in machine learning, like to feed data to your model. Okay, and to train your data, to test your data. Okay, and we use in AI, neural networks, web development, application development, so GUI. So why we can use Python everywhere? Because of the vast amount of libraries and features. Oh, sorry, frameworks. Okay, suppose for the cybersecurity, we can use multiple libraries. Okay. For the networking, we can use like request sockets. For the automation, we can use Selenium, PyAuto, GUI. For the GUI, we can use Kinter. For the data science, we can use Pandas, NumPy, Matplotlib, Seaborn. Okay. More else, Plotly, Cufflinks, etc. For the ML, we can use Scikit. Okay. We can use TensorFlow. We can use Flask. Okay. For the AI as well, we can use. Okay. And for the website, we can use Django as a framework. Okay. For the backend development in Python. Okay. So there are like many libraries and frameworks in the Python. Okay. So the softwares we have. So we will use first we will use Python. Okay. Second, we will use Python 3. Second, we will use IDEs. Okay. And IDEs we use VS Code. It is Visual Studio Code. Now, what is IDE here is IDE means integrated development environment. Okay. So we will use Python 3. We will use IDE as a Visual Studio Code. Okay. So IDE is like environment where we can freely code, where we can code with various types of syntax colors. Okay. So IDEs are like very flexible. Okay. So for the installation process, so how to install Python? So we will install Python as well as IDE. Okay. So for the Python, you have to visit the website that is python.org. You can search for the Python. Download from here. Okay, click on here python.org. So click on here Python, download Python. Okay, then for the IDE, that is Visual Studio. So you can search for the Visual Studio Code, download. Click on here. So it is available for the Linux, for the Mac, for the Windows. Okay, so it is a cross platform. Even Python is a cross platform. You can use it on any platform like Windows, Mac, or Linux. So click on download here for the Windows. Okay, or for the Mac, whatever you are using, or for the Linux. Okay. Now, for the installation process, so the installation process of Python 3 is like it is a straightforward. Okay, just click on next install, and whenever you are installing a Python, just take an option that is add to path. Okay, so whenever you are installing a Python 3, okay, so you have to take this option that is add to path, and then click on next and install. So this will install your Python successfully. And for the IDE, okay, so the installation process for IDE is also straightforward. Just click on next install. Okay, so this will install your Python. 3 as well as IDE. Now, so let's open the IDE here. Okay, so this is the icon of your IDE. So open it. So this is the interface of your IDE. Okay, so from here, you have to click on Files Explorer, click on here, Extensions. So with this IDE, we have to install some more extensions. Okay, like we have to install. So first we have Python. Okay, why Microsoft? Second we have Run. Okay, that is Code Runner. We have Code Prettier, and we have VS Code icons. So these four extensions are very useful for the VS Code. Okay, so let's install it one by one. So first search for Python here, and here. Okay, so that is Python from by Microsoft. Click on install. Okay, then search for the code runner. Okay, so click on install here. Then search for the VS Code icons. VS Code icons. Okay, so from here, install VS Code icons. Then code editor. Okay, so here this is used to format your code. So install it. Okay, then restart your VS Code. Okay, so after installing the extensions, restart your VS Code. So this is how you can install in Windows. Okay, now for the Linux. So now let's see the installation process for Linux. Okay, so I will show you the installation process for the Debian-based systems like ParrotOS, Kali Linux, Ubuntu, TasteOS, etc. Okay, so open your Linux machine. Okay, if you have any Linux machine, then open it. So I will use ParrotOS. Okay, you can use any Linux machine. Okay, so Okay, so for the installation process in Linux, you can search for sudo for the root permission, apt get install Python 3, password of your machine. So this will install your Python 3 inside your Linux system. Same as you can try with Python only. Okay, this is for Python 2. If you want to install your Python 2 inside your Linux, so you can type sudo apt-get install Python. So this will install your Python as well as Python 3. Okay, so this is how you can install your Python as well as Python 3 inside your Linux machine. Okay, I hope this much is clear. Okay, let me shut this down. No. So this is all about the installation process. Now we will discuss Python basics versus Python advanced. So there are like two types of Python. We can divide Python in two types. So you can type command here. Okay, so this is for Python 2 and this is for Python 3. Okay, now, so we have two types of Python, that is Python basics and we have Python advanced. Okay, so Python basics cover all your basics part, like your fundamentals, your introduction part, your variables, data types, operators, loops, conditional statements like if, else, while loop, for loop, and break statement, continue statement, functions. Okay, user defined functions, modules, packages, and more else, file operations, exceptional handling. Okay, and a little bit concept of OOPS, that is classes and objects or regex. Okay, so in Python basics, we will cover. Now in Python advanced, we will cover the advanced part. That is the advanced part of OOPS, that is encapsulation, inheritance, or polymorphism, abstraction, etc. Then we will cover that libraries. Okay, like we have basically the course that is provided by JNtech. It is a combination in the Python Advanced. Like it is a combination of like all the libraries, all the most popular libraries like SQL, connector, okay, networking, and we have multi-threading, CGIs, GUIs. Okay, like in GUI we have Kinter. Okay, so let's discuss the course content first. Then I will show you. So we have Python basics and advanced. Okay, so this is the course content of Python basics. Okay, which is of 50 hours. The duration is 50 hours, and for the advanced Python, it is of 40 hours. So first, we will discuss in Python core. So we will discuss introduction to Python, like basics of Python, like why Python. Okay, Python program comparison, like with Python 2 and 3, advantages of Python, history of Python, installing process, ideal, that is IDE of Python. Okay, and how to execute a Python program using ideal. Okay, that is like ideal means a Python IDE only. Okay, which comes pre-installed with Python only. Then we have Python fundamentals. Okay, so in this session, we will discuss about Python tokens, keywords, identifiers, literals, and operators. Okay, and then variables, assignments, input, output, function. Now, in the data handling, we will discuss about data types. Okay, like we have various types of data types in Python. We have numbers, we have strings, we have float, complex, integers, list, tuples, dictionaries, set, frozen set, boolean. Okay, then we will see the mutable and immutable types and typecasting. Then we will see the string manipulation. That is string manipulation, list manipulation, tuples manipulation, dictionaries manipulation, and set and frozen set manipulation. So manipulation means the functions and methods only. That mean We will see the string functions methods. We will see the list functions in methods, tuples functions in methods, and so on. So we will see the data types, functions, and methods, like what which function we can use with which data type. Okay, how many methods are there in a particular data type, etc. Okay, so in the string manipulation, we will see how we can access the individual elements from the string. Okay, from a piece of string. Then we have string operators. Okay, how we can slice the strings. Then we will see string functions like other functions and methods like len function, uppercase, lowercase, okay, etc. Is alpha, is numeric, replace, etc. Then list manipulation. So in this session, we will see how we can create list, how we can access it, how we can join, how we can modify, how we can replicate. Replicate is like copy. Okay, how we can slice it. Now in the tuples session, we will see how, into part of tuples, how we can create tuples, how we can access, how we can join it. Okay, how we can replicate, how we can slice it. Okay, same as list. Now we have dictionaries, same as with our dictionaries. So how we can create dictionaries, like what is dictionary in Python? Okay, and what is JSON in Python? Then how we can access values, how we can work with dictionaries, how we can like access the key or the value of the dictionary. Okay, and the properties of dictionaries, like same functions and methods. Then we have set and frozen set. It is like we will see how we can create set, how we can create frozen set. Okay, which one are mutable, which one is immutable, etc. Then we have operators. So we have like various types of operators. We have arithmetic, we have relational, logical, membership, identity, bitwise, assignment operators. Okay, then we have operators precedence. That is the rules of operators. Okay, then we have evaluating expression that we will see. Okay, so we will discuss each and every operator, each and every concept of operator in detail. Then we have program control flow. That is like we have conditionals as well as we have loops inside control flow. That is, we have if statement, if else statement, if elif, and nested if. Nested if is like if inside if, means we are using if statement inside if statement. Then we have indentation. Okay, then we will see the looping and iteration. So iteration is also known as looping. So we will see we have two types of loops in Python. We have for loop and we have while loop. So we will see that. Okay, and we will see loop as a statement. We will see nested loop, how we can use loops inside loops. Okay, we will see the break and continue statements, the range function, etc. How to use range and like what are the arguments inside range. Basically, we have three types of arguments like step, stop, or start. Okay, we will see that. Then we will see the functions. Okay, that is we have two types of function in Python. That is user defined and built-in functions. So we will see how what are the built-in functions like and what are user defined functions and how we can define functions. Okay, as we know, user defined function means the user defining the function. So we will see how we can define the functions. Okay, that is using a function Python function types. Okay, etc. So we will see various types of function that is our built-in. We will see how we can create our own functions. Okay, we will see the flow. We will see the nested functions like functions inside functions. Okay, we will see the arguments, parameters, and the scope of variables, basically local variable or global variable, lambda function, recursion, etc. Okay, recursion function is like function calling itself. So we will see that. Then we have modules and packages. So inside modules and packages, we have built-in modules and we have user-defined modules. Like we can create our own modules also. So we will see how we can create our own modules, how we can use Python modules. Okay. So we'll see different modules. Like we will see OS module, we will see time module, date time modules, calendar, system modules. Okay, and etc. Then we have file operations. So in this file operation means we are how we can open a file with the help of Python. Or how we can open a file, how we can read a file, how we can modify a file, how we can remove a file, how we can make update a file using file operation. Like how we can write into a file, how we can update a file, how we can append a file. Okay, we can open how like in which way we can open a file. We can open a file in the form of text and bytes. Okay, like in a text format or in the binaries format. Okay, if your file is a in a like is a tst or Excel file, then we can open it in a text format. But if your files are images, okay, then we have to open it in a binary format. So we will see how we can open a file, how we can read a file, write a file, okay, etc. How we can open the Excel file inside Python. Okay, that is like useful for the data science. Okay, then we will see the regular expression. That is like regular expression is like finding a particular expression. Okay, suppose there's a book of 500 pages, and you have to find a particular word or letter. Okay, or you can say a statement. For that purpose, we will use regular expression. Okay, so we will use how we can match objects with the that with inside the book. Okay, so we have match function, search function, grouping, matching, etc. Okay, so we will see that flex. Now, then we have exceptional handling. That we see we have basically try and except block in Python. Okay, to handle the errors. So we will see how we can handle the errors using exceptional handling. So we will see how we can raise an exception, how we can create our own exceptions. We will see the try and except block, etc. Okay, and we will see how we can use try, except, and finally an else block together. Okay, then we have classes and objects. Okay, that is the basics of the OOPS concept. So we will see what is classes, how we can create our own classes, what is objects. Okay, basically classes are the blueprint of a blueprint. It is like a blueprint, and objects is like instance of a classes. Okay, so we will see how we can create classes, how we can use our parameter inside classes, how we can use methods, how we can use functions, how we can create functions and methods or variables inside classes. Okay, we will see that. And how we can use those variables, functions, or methods using objects. Okay, because classes are just like a blueprint. Okay, so for using the objects, so for using the functions, methods, or variables inside classes, we have to use or we have to make an object. And on the basis of that object, we will use all the functions, methods, or variables inside classes. Okay, like this much more. So this is like the basics of like the core Python. Okay, basics of Python. Then we have advanced Python. So in this session, we will discuss advanced Python. That is of 40 hours. Okay, so course duration is like 40 hours. So in this, we will discuss about first introduction to OOPS. That is the object-oriented programming approach. Okay. So first we will discuss procedural and modular programming. What is OOPS concept? In this concept, we have like various concepts like we have encapsulation. We will see what is encapsulation, inheritance, polymorphism. Okay, what is data abstraction, data hiding, etc. Okay, so we will discuss it in detail. Then we have now from here we will start with the libraries. Okay, the useful libraries used in multiple domains. For example, we have database. Okay, so in this we have MySQL database. So we will see how we can connect a Python with a database. Okay, how we can run the SQL queries with the help of Python and SQL. Okay, so for that we will use a MySQL connector and we will use a MySQL. Okay, so we will see the MySQL queries as well as we will see how we can connect to Python and like SQL together, etc. Now, then we have GUI programming. So in this session, we will see how we can create a GUI applications or programs using Python. Okay, so in this GUI programming, we will use Kinter and Turtle. Okay, so we will see the widgets of of the Kinter like frame, button, label, entry. Okay, we will see different types of entries, frames, how we can create frames, labels, buttons. Okay, we will see the features of these, all of these like which color to choose, BG color. Okay, and border, height, width. Okay, how to create a main window, how to loop through a window, etc. So we will see that. So in the GUI, we will discuss the Kinder. Second, we will discuss Turtle. Okay. Then we will discuss Turtle programming. That is basically it is used for the animations. Okay. So we will see how we can control Turtle, how we can perform animation programming using Turtle. So we will create various animation using Turtle. Okay. Then we have multi-threading. Okay, in this we will see what is thread versus what is process. Okay, difference in the thread and process, how we can start a new thread using Python, how we can run multiple threads at the same time using multi-threading. Okay, we will see threading modules, etc. So we will see all about threading in that Python. Okay, so next we have networking. So in this we will see what is like how we can use socket module or request module inside networking. Then we will see the server and client socket, how we can create a server and how we can create a client and how we can connect them together. Okay, so we will see connecting client server and we will make our project that is client server chatting program. Okay, basically we will create various projects inside basics and advanced part of Python. Okay, so then we will see some more advanced concepts, that is decorators, generators, iterators, and coroutines. Okay, we will see what is decorators. Decorators are the functions which is used to modify the another function. Okay, that we will see. Generators, iterators, and coroutines. Like they are like very broad concept, and they are like important as well. So we will see that. Then we have CGI. Okay. CGI is basically related to website. Okay, so we will see the architecture of CGI, how we can create our CGI environment variables. We will see the get and post methods. We will see how we can create cookies, how we can upload a file, how we can create a HTML interface. Okay, how we can connect to HTML with your Python, etc. Okay, so these are some few basics, advanced libraries for Python. Okay, these are very popular ones. Basically, you can use these libraries everywhere in every domain. Okay, suppose you want to suppose there's a CLI project and you want to give a interface or a GUI model or GUI interface to your CLI project, then you can use Kinder. Okay, if you want to connect your login page with your database, then you can use MySQL with Python. Okay, so like there are like many bases. So basically, we will see these libraries one by one in Python advanced module. Okay, so after the like with each and every module, we will see the projects. Okay, we will discuss the projects. So we will create projects because projects are very important for Python. Okay, because if you are not implementing whatever you have learned so far, so Python is of no use or any programming is of no use. Okay, if you're not implementing that knowledge. So programming are basically for the development. So we have to develop the projects. Okay, you can bring your own new ideas. So I will help you in that, or I will bring my new ideas. So we will discuss that together. Okay, we will see some basic projects for number tracer. We will see the how we can create malwares using Python. We will create a network. We will create a chatting app. Okay, that is how we can like create a chatting program that is like one to one and one to all. Okay, how we can create a group chatting program, how we can create a one-to-one chatting program. Okay, then we will see some projects from the GUI. Okay, basically we can see both CLI projects and GUI projects. Okay, in the CLI we will see the phone number tracer, malware, how we can create a malware. Okay, how we can create a login form. Okay, then we will provide them an interface that is a GUI interface. So we will see in the GUI we will see how we can create a music player. Okay, how we can create a test editor, and we will see how we can create a network chatting app. Okay, like how we can create a chatting program that is one to one and one to all. Okay, and we will see how we can create a website. Okay, fully fledged website with the help of Python and CGI. Okay, more as we will see how we can create a login form, how we can create a payment gateway with the help of Python. So we will see that one by one. Okay, we will see like we will do around 10 plus projects in Python. Okay, and if you have any idea, like if you are bringing your own idea, so that is also welcome. Okay, so I will help you in that in those ideas also. Okay, so this is all about projects and Python course content. Okay, so I hope this much is clear. Now we will move to how we can write our first code. That is, first we will see how we can write code in Python ideally. Okay, here we can write So Python ideal stands for integrated development learning environment. Okay, so open your search for Python ideal. Okay, open it. So here you have to write, let's say print hello world. Enter. So here, so here print is a function which is used to print something. Okay, which is used to display something. Or and like whatever you are writing inside parentheses, so print will display that. So print is a function here. Okay, that is a Python function only. Okay, and we have write hello world. So this will print or display hello world as it is. Okay, so this is how you can use Python ideal. Okay, this is a Python shell, but we will use IDE. We will use a VS Code. Okay, so open your VS Code from here. Now, so first we will create a folder here. That is, let's say, okay, name your folder. Okay, so this is my directory. So drag it over the VS Code icon, open it. So cross this. Now here we can, so this is the interface of the VS Code, which is very simple. Okay, from here file, you can create new file, new window, you can open new window, you can open any file, you can create any file, you can open any folder, etc. Okay, in the edit, in the file, there's an option of preferences where you can edit your color theme. Okay, where you can modify or like update your color theme, change your color theme, or you can check out the keyboard shortcuts. Okay, then here we will now in this explorer we can create new file, new folder, we can refresh. So here we click on new file, name your file. Let's say my file is first.py. Okay, so the extension of Python is .py. And here you can see the icon of this Python. Okay, that icon. So this is because of that VS Code icons that we have installed. Okay, that extension, VS Code icon extension. Okay, now here, so we can write here print hello world. Okay, now save it, run this. So you can run with the help of this button. Okay, so this is because of the code runner. Okay, that we have installed. So click on here, code runner, it's this button, and here you can see we have hello world here. Okay, so print is a function here which is used to print something or which is used to display something. Okay, here we can print like we can print anything. Python is a powerful language. Okay, save it, run it. So we have hello world as well as Python is a powerful language. So this is how you can run your first code. Okay, now. So this is all about Python introduction. Now we will see the Python fundamentals. Okay, so in this we will see tokens, keywords, variables, naming conventions, data types, mutable versus immutable data types, typecasting, comments, indentation. So here we have tokens. Okay, so what are tokens here? So we can write here tokens are the smallest unit in Python. Okay, basically everything is token in Python. Basically the smallest unit in any programming is known as token. Okay, so we can set it a variables. Variable is a token. A string is a token. Okay, a number, a integer, a complex number, a float number. These are all known as tokens at a very low level. Okay, like at a very base level, They are all known as tokens. Okay, just like we have a cell. Okay, like cell is a building block of our body. Okay, same as we have tokens. Tokens are the building block of any programming language. So here we have our tokens. Then we have keywords. So what are keywords here? So keywords, we can say that keywords are the reserved words for Python. Or we can say that of Python. Okay, so keywords are the reserved words of Python. Okay, which means they have. So now we have keywords. So keywords are the special is are the reserved words for Python. Okay, they have a special meaning for the Python interpreter. Okay, so like suppose there's a dictionary for Python. Okay, there's a dictionary of Python which we in which these keywords are listed. So we cannot use these keywords anywhere. Okay, they have a special meaning for the Python interpreter. Okay, suppose print. Print is a function which is used to print something. Okay, so we cannot use this print function as a variable name. We cannot use this print function as a class name or function name or etc. Okay, so these are the reserved words for Python, and we cannot use it anywhere apart from these specific uses. Okay, like print is a specific print have a like a has a specific use. For has a specific use. Okay, so we cannot use it anywhere apart from their specific uses. Okay, so they are like keywords are the reserved words for Python. Okay, they have special meaning for the Python interpreter. If you are using any of these reserved words, like we have more words, like we have print, for, while, if, else, elif, we have and or not, we have is, not is, okay, is not, sorry, in, not in, and we have more else, we have XOR, etc. Okay, so we have like these special words. We cannot use it anywhere. Okay. Suppose you are using this print statement as a variable name. So at that time, Python will throw an error because for Python interpreter, print is a reserved word and we cannot use it anywhere. Okay, apart from its specific or intended use. Okay, so these are known as keywords. So keywords are the reserved words. Okay, so now we have variables. So what are variables? Variables are the variables are the container which is used to store your value. Okay, so we can mention here variables are the container which is used to store your value. Okay. For example, so here we have a value that is John. So we are assigning this John value to a variable name. So name is a variable here, John is a value here. Okay, so here we are assigning a John value to a variable name. And we are assigning with the help of assignment operator, that is this equal sign. Okay, so here we can mention here. So name is a variable here. John is a value here. Okay, John is a value for the variable name and equal sign is the assignment operator. Okay, So we are assigning a value John to a variable name. So we can say that variables are the container which is used to store a value. Okay, you can store any type of value. You can store strings, you can store int, integers, float, complex, list, tuples, etc. So they are just like a value, they are like just a container which is holding your value. Okay, so now we have some naming rules or naming rules of naming a variable. Okay, so we have some rules of naming the variable. We cannot name a variable anything we want. Okay, so there are some rules we have to follow while naming the variable. Okay, so these rules are known as naming conventions. Okay, so first rule is spaces are not allowed. Okay, so basically spaces are not allowed. We cannot use a space in our variable name. Okay, but we can use underscore in place of spaces. Okay, if you ever want to use a space, so you can replace it by underscore. Okay, for example, suppose we have a name, let's say first space name equal John. Okay, so here first is a name. Okay, like here first name is a variable here. And here we are using a space. So this is a invalid variable. Okay, now here we have first underscore name, that is John, which is a valid variable name. Okay, so spaces are not allowed. We can use underscore in place of spaces. Okay, so this is invalid and this is a valid variable name. Okay, because we are using underscore in place of space. Now, second we have special characters are not allowed. Okay, so special characters are like, okay, is it true? So basically special characters are not allowed. Okay, so basically you cannot use. Okay, so here you are using a special character like at the rate or exclamation mark. So these are special characters and we cannot use special characters inside a variable name. So we can say that it is an invalid variable. Okay, so here we can mention it is also an invalid variable. So we cannot use special characters inside a variable name. Okay, now so we cannot start the variable name with a number. Okay, so that are not allowed, but we can use number in middle and at last. Okay, so make sure you are not using number in at the starting of a variable. Okay, so that is invalid variable name. Okay, so basically numbers are not allowed. Okay, but we can use number in middle and at last. That is a valid variable name. Okay. Fourth, so we can start the variable name with uppercase, lowercase, and underscore. Okay, for example, okay, or we can use name, dimension age here. Okay, so we can start the variable name with uppercase letter, with lowercase, and with underscore. So these are all valid variable names. Okay, so here we can mention these are valid variable names. So we can start the variable name with uppercase, lowercase, or underscore. Then, okay, so always name your variable according to your value. Okay, so basically it is not a, so this is not a compulsory point. Okay, for example, suppose you are asking, you are inputting a age inside a variable. Let's say age equal 18. Okay, same time you are using a equal 18. Okay, so always name your variable which is related to your value. Okay, whatever value you are storing, okay, not a data type, a value. Suppose you are storing someone's age inside a variable. So simply name your variable age. Okay, don't name this A or 18 or B or your any name. Okay, so that is not a good practice. Okay, so you can always you can try this, or it is not a compulsory point, but it is a good practice to always name your variable related to your value. Okay, whatever your value is, you are naming your variable for that. Okay, related to that. That is, we have 18. 18 is a value here. Okay, basically 18 is a age. So you are inputting a age inside a variable. Okay, and you are calling this age. Okay, if you are asking for age, okay, in that case, now here like you are storing a age here. Okay, 18 is a age here, but you are naming your variable a. Okay, so this is not this doesn't make any sense. Okay, so always name your variable which is related to your value. Okay, so we have these five simple rules. Okay, you have to follow these rules, and these rules are known as naming conventions, which is rules of naming the variables. Okay, so spaces are not allowed. You can use underscore in place of spaces. Special characters are not allowed. Okay, so you cannot use special characters inside your variable name. And we cannot start your variable name with number, but we can use variable numbers in middle and at last. Fourth, we can start variable name with uppercase, lowercase, and underscore. Okay, more or less, point number 5, always name your variable that is related to your value. Okay, so these are known as naming conventions or variable names, rules for naming the variables. So you have to follow this. Okay, now let's try this inside Python interpreter. So here we have, let's say, name equal John. We have age equal 80. Okay, so name and age are name and age are variables, and John and 18 are values. So we are assigning John value to name variable. Now we can print here name and we can print here age. Means we are calling the variable name and age. Okay, which will print the values. Okay, you can see John 18. Now let's see if we are putting first and this name. See, so this will throw an error. You can see a red line here, underline here. That is, so this will throw an error because we are using age in variable name. Sorry, we are using space in variable name. So we can put underscore, okay, in here. So we have to modify this as well. Underscore name. Okay, so that is John and 18 age. Okay. Same as we cannot use any special characters like this. Okay, so this will throw an error. When you run this, you can see that we have a error. 1 second. Yeah. You can see invalid syntax because we cannot use any special characters inside a variable name. Okay, or you are using, let's say, number at starting. Okay, see, one age. So this will also throw an error. Okay. See, when you run this, so this will throw an error. That is invalid syntax, decimal literal. Basically, we cannot use numbers in variable names like at the starting, but we can use in middle. For example, we can use at last num1. Okay, and we have to modify this as well, num1. So here we can run this. John 18. Okay, so John is a name here. Age num1 is a 18. Okay, value of num1 is 18. Okay, so this is how you can name your variables. Okay, you have to follow these rules. Otherwise, Python will throw an error. And who wants error? I think no one, right? So here now we have data types. Okay. Now what are data types? So data types are the types of value you are storing inside a variable. So we can mention here data types. So data types are the types of values we are storing inside any variable. Okay, that are known as data types. Suppose here we have a it's right here ABC or A. Okay, so here 10 is a value and A is a variable, and we are assigning 10 value to A. So here data type is this value. That is, which type of value we are storing inside any variable is known as data type. Okay, so data types are the types of value we are storing inside any variable. Okay, so we have various types of data types. So here we can mention types of data types, or just mention data types only. Okay, so we have strings, we have numbers. Inside numbers, we have integers, float, complex, numbers, float, numbers. Okay, just float numbers and integer numbers. Okay, now we have strings, numbers, we have boolean. Inside boolean, we have true and false. Okay, then we have list, we have tuples, we have dictionaries, we have set, then we have frozen set. So we have these types of data types. Okay, we have strings, numbers. Inside numbers, we have integers, float, complex. We have boolean, we have true and false. inside Boolean, we have only two values, that is true and false. We have list, we have tuples, dictionary, set, and frozen set. Okay, so here what are strings? So we can mention here any character or group of character inside quotations, inside single um okay. So what are strings? So strings are the group of characters inside single, double, and triple quotations. Okay. So these are known as quotations. These are double quotations. These are single, and you can see that these are triple quotations. So any character, okay, like any character. So here we can put numbers. Okay. So now it can be numbers, it can be special characters. Okay, like okay. So these are all known as strings. Okay. So inside strings we can use anything. We can use special words, like we can print anything inside, like strings. We can use special characters, we can use reserve words, we can use sentence, we can use numbers. So here this is not a number anymore, it is a character or a group of character. Okay, so these are known as strings. So any character inside double, single, or triple quotations are known as strings. Okay, no. Then we have numbers. So we have integers, which is like simple numbers. Okay, like we have without decimal numbers. Okay, like simple real numbers. Okay. Then we have float numbers. They are like decimal numbers. Okay. Suppose point numbers, which is known as floating point numbers. Okay. So we have this float numbers, integer numbers. Then we have this complex numbers, which is like 1 plus 2j. Okay. So 1 and 2 here is a real number. Okay. So complex number is like combination of real and imaginary number. So 1 and 2 here is a real number and j is an imaginary number. Okay. So these are known as numbers, complex numbers. Okay. Then we have Boolean values. So inside Boolean values, we have only two values, that is true and false. So whenever you are using Boolean values inside Python, make sure this T should be capital of true and F should be capital of this false. Okay, so whenever you are using any Boolean values, make sure this, okay, T and F should be capital of true and false. Then only they can be called Boolean values inside Python. Okay. So we have some short form of these all. Okay, so basically strings are also known as str. Okay, that is str inside Python. Integers are also known as int in Python. Okay, like short form. Float are also known as float only, no short form. Complex are known as complex only, no short form. Booleans are known as bool. Okay, so let's try this one by one. So here we have, let's create a variable name. Okay, John. Age 18. Okay, we can say any variable. Let's say b. Okay, Okay, so we have some bunch of variables. Okay, we have name. So here this is a string. This is an integer value. Okay, a float value, complex, Boolean values, true and false. Okay, see, we are using T as a capital here. Let's put T small. So this will throw an error. Okay, so always put T in caps if you are using true or false. Okay, inside Python. So now what we can do, we can check the type of value the variable is storing with the help of type function. So here we can mention some group of functions as well. Okay, so we have print function, which is used to print or display something. Second, we have type function, that is checks the type of value the variable is storing. Okay, so we have print and type. So now we will try type. So you have to write print type. Now which value you want to check? Means which variable value you want to check. So you have to name here. So name. Now here we are checking the name variable, like which type of value your name variable is storing. So you can run this here. You can see str, that is string. Okay, that is class string. So here your name variable is storing a string value. Okay, now we can check for age, num1, comnum, a and b. Okay, so here we can put type of value your age variable is storing. Print. So here we are checking for each and every variable, like we are checking on the type of value we are storing inside name, age, comnum, A and B. So name is storing string value, age is storing that integer value, num1 is storing float value, complex number is storing this, comnum is storing complex number value, A and B are storing Boolean values. And when you run this, we have the output here. You can check it. We have this string, we have this int for this age, string for this name, num1 for this float. We didn't print this. Print type of value num1 is storing. Now we can run this. Okay, so string, integer, float, and complex number is this one. Okay, and we have these Boolean values, which is also known as bool in Python. Okay, short form of Booleans, true and false. Okay, so this is how you can use a type function to print a type of value we are storing inside any variable. Okay, so I hope this much is clear. And more else, whenever you are making any change in this file, suppose you have write, let's say another variable, let's say b c equal 12. Okay, now here you can see a little dot here. Okay, this white dot. This means you have to save your file. Okay, so whenever you see this dot here, means your file is unsaved. So press Ctrl S to save your file, and then only your changes can be saved. Okay, Ctrl S. Now see, you can see that your dot has been removed from here. So this is how you can save your file, and then you can run this file. So whenever you are running a file, okay, suppose you have make some changes or you are like fixing some error. So click on Ctrl S to save your changes. Okay, then run your code. Okay, so we have these output. Okay, so we have strings, numbers, and inside numbers we have integers, float, and complex. And then we have Boolean values. So now we will take 5 minutes break. Okay, and we will continue after 5 minutes. Okay. So you can visit the JNtech website until, like, if you want to check the course content, then you can visit the JNtech website. So now we can continue. So now we will discuss other data types like list, tuples, dictionaries, set, and frozen set. Okay. So list are inside square brackets. Okay. We can input, like we can put any type of data type inside list. Okay. Any number of data type, sorry, any number of data or elements or any number of data type. Okay. Like any type of data type. For example, we can store a string. Okay. We can store a set of or bunch of string. We can store numbers. We can store that float numbers. We can store Boolean values. Okay, and we can store even list inside list. We can store tuples inside list, dictionaries inside list. So inside list, we can store any type of data type. Okay, so let's store a list inside list. Let's say a value of a list of numbers up to 7. Okay, so list is like we can store any number of elements and any type of data type inside list. Okay, and we create list using square brackets. Okay, then we have tuples. So we create tuples using the parentheses, that is round brackets. Okay, same as we can store any type of data type inside tuples. Okay, we can store strings, float numbers, complex number, booleans. We can store list tuples inside list. We can store listings that tuples inside tuples, dictionaries inside tuples, set or set inside tuples. Okay, so we can store any type of data type in tuples also. Now with dictionaries, so dictionaries are like key value pairs. Okay, so we can say that they are like key value pairs, and we create dictionaries using curly braces. That is, dictionaries is a combination of key value pairs. So in this we have a key and we have a value. Okay, so key is like, let's say a name. Name is a key here. Okay, value is John. Okay, name John. Comma, we have a key here, age, and we have a value here, 18. Same as we can store list inside dictionaries, we can store dictionaries inside dictionaries, we can store tuples inside dictionaries. Okay, for example, we can store, let's say we have a string fruits. Okay, here we have a list of some fruits. Okay, or we can store dictionaries inside dictionaries. For example, we have some a dictionary, let's say alphanum. Alphanum. Okay. Here now we can create another dictionary as a value of this key. So we have this, let's say A1. Okay, so here we have a name. Name is a key here, separated by a colon, and John is a value here. Okay, and this is one key value pair, and this is second key value pair, which is separated by a comma. Okay, so we have this name is a key, and John is a value, which is separated by a colon. And we have another key value pair, and age is a key here, 18 is a value, which is separated by a comma. Okay, that is two key value pairs. Now, same as we have in this, we have one key value pair, that is fruits is a key, and we have one value of this fruit that is in the form of list. Okay, so we have this list here. Okay, and list is a value of this fruits key. So fruits is a key which is separated by a colon, and we have this value. Same as we have alphanum. Alphanum is a key here, separated by colon, and we have this value. Now we have this value in the form of dictionaries. Okay. So alphanum is a key and value we have this dictionaries. So inside this dictionary we have three key value pair. Okay, you can see one key value pair, we have second key value pair, and we have third key value pair. which is A is a key, 1 is a value. B is a key, 2 is a value, C is a key, 3 is a value. So we have a whole dictionary as a value of this alphanum key. So we can say that we have this dictionary inside dictionary. We can say that list inside dictionaries. We can say that string or numbers inside dictionaries. So we can store any type of data type inside any type of inside list, tuples, dictionary, set. Now we have said that is we can make this inside curly braces. Okay, we have this. So set also stores any type of data type. They can store strings, they can store numbers, float, boolean values, list, tuples, dictionaries. Okay. So now what is a and frozen set? Yeah, frozen set is like they don't have any specific format. Okay, we will see that. So basically, we have these four data types. So let's create this inside VS Code. Okay. Suppose we have this list underscore one. Okay. So here we can mention a list of strings. Okay, we have some value here. We have some boolean value, and we have some list inside list. Okay, that is, let's say we have some values. Okay, now we can print this list underscore. Now we can check the type of this list underscore one. Okay, save it, and we can run this. So here we have this list. Okay, apple, cherry. This is a list, and this is a type of list. We can check the type of variable, type of value the list underscore one is storing. That is a list itself. Okay. So here you can check where apple is element here, cherry is element, grapes is element, 1, 2, 3, 4, 5 is element, 2 is element, and this list is a single element. Okay. So the components inside list are known as elements. So apple is a single element, cherry is an element, etc. Okay, now we will create a tuple underscore one. Okay, now use parentheses for this. We can copy this here. Okay, so a tuple can store any type of data type, a string, a numbers, a boolean values. Okay, even a tuple inside tuples, that is this one. Okay, we can store any type of value. So now we will print it, print tuple underscore one, and we can check the type of value they are storing, that is tuple underscore one. Okay, now we can run this. So here you can check this is a tuple. Okay, and class is tuple, which means which type of value you are storing. Okay, now we have dictionaries. So dictionary underscore one. So we have this inside curly braces. So dictionaries are like key value pairs. So let's create a key. Name is a key, colon, your value here. So value is also in the form of string. Then we have this comma, which is a separator between one key value pair and another key value pair. So we have this age, we have this 18 here. Okay, 1 second. So name is a key here and John is a value. Age is a key here, 18 is a value. So this 18 is in the form of string, sorry, integer. Okay, now we can check the type of value. your dictionary is storing, or we can check we can print the dictionary itself. Okay, and then we can print type of value your dictionary is storing. Okay, so run it. Okay, so we have this dictionary. Okay, and we have this class dictionary. Okay, now then we have set underscore one. So use curly braces here and then your value here. Okay, so you can store any type of value. You can store set inside set, dictionary inside set, tuples or list inside set. Now we can print the set underscore one, or we can print type of value your set underscore one is storing. Okay, now here you can check. This is a set, and we have this value set here, class set. Okay, so now what is the difference in the set, tuples, dictionaries, and list? So the difference is of mutable and immutable. Okay, so we have this mutable data type, mutable versus immutable. So what is mutable and immutable? So mutable means we can change it. Okay, change. We can say we can modify or change a data type after creation. Okay, we can just mention here. Now, immutable is like we cannot change. So we have mutable and immutable data type. So mutable is like we can change or we can modify the data type. For example, we can suppose mutable is like, so we have list is mutable in nature, and that dictionaries are mutable in nature. Then we have immutable, that is tuples and set. Both are like we can mention tuple only. So basically, list and dictionaries are mutable in nature, which means we can modify the list after creation. Okay, we can modify the dictionaries, we can modify the list. We can add value, we can remove any value. For example, we have this list. Okay, suppose we have this list. So apple is an element here, cherry is an element here, grapes 1, 2, 3, 4, 5, 6.7, 7.8, 2, or this whole list is the element here. Okay, so we have this. These are known as elements. So mutable means we can modify the value of these elements. Means we can change the value. Suppose we can replace apple with banana. We can replace this value with any other value. We can replace this true with false. Okay, so we can change the value of these elements, as well as we can add values. We can modify. We can remove any value. Suppose we want to remove apple, so we can remove it. We want to if you want to add any value. Okay, apart from these values, we can add this. Okay, like if you want to add banana here, so we can add. If you want to add 7 here, we can add. Okay, so in the list, which is mutable in nature, we can change values. We can change the values of the elements. We can replace elements. We can add value. We can remove values. Now in tuples are like immutable in nature. Okay, they are like we can mention here mutable in nature. They are like immutable. Okay, so tuples are like immutable in nature, means We cannot modify the tuples. We cannot change it. Like we cannot change the elements of the tuple. We cannot replace any element. We cannot add. We cannot remove any values. Okay, that is the means of immutable in nature. Like we cannot change the value of apple. Okay, we cannot replace any value. We cannot add any value. We cannot remove any value. That is known as tuples. Okay, they are like immutable in nature. Now we have dictionaries. So dictionaries are like mutable in nature. Okay, means we can change the values. Okay, we can like remove any value. We can remove any key value pair. We can add any key value pair. We can modify any values of the keys. Okay, so we can say that dictionaries are mutable in nature. Okay, then we have set. So basically, set are both mutable and immutable both. Okay, so set are mutable and immutable both. How can a set is like mutable and immutable both? See, we can mention here elements of the set are immutable in nature, which means we cannot modify the elements of the set. Suppose if you want to modify any value, if you want to modify this apple value with another value, like if you want to modify this apple with banana, okay, so we cannot modify these values. That is why we can say that elements of the set are immutable in nature, and these are known as elements. Apple is an element, cherry is a element, grapes is a element, one is an element here. So elements we cannot modify or we cannot change the values of the elements, okay, inside set. But we can add value or we can remove value. Okay, so we can say that set itself is mutable because we can add or remove the values inside set. We can mention values or we can mention elements. Okay, so set itself is mutable because we can add values, we can remove values or elements inside set, but we cannot modify it. Okay, so we cannot modify. So we can say that elements of the set are immutable in nature because we cannot modify them, modify or replace the values of elements. Okay, so that is why we can say that set and set is both mutable and immutable. Okay, now because of this nature of the set, that is like a set is both mutable or immutable, we have frozen set. So frozen set is immutable in nature. Okay, so to make set fully immutable, we use frozen set because frozen set is fully immutable in nature. Fully immutable means just like we have tuples. Tuples we cannot change values, we cannot add value, we cannot remove value. But in set we can add value or remove value, but we cannot modify it. So we have a nature of set that is they are both mutable and immutable. So to make your set fully immutable, we use frozen set. Okay, that is to make your set fully immutable in nature. Okay, so I hope this much is clear. What is mutable, what is immutable, and which data type is mutable and which data type is immutable. Okay, so now next we have typecasting. Okay, so typecasting is a very important concept of Python. Okay, so typecasting means changing your one data type to another data type. That is known as typecasting. Okay, here you are changing your one data type to another data type is known as typecasting. For example, you are converting a list into tuple, or you're converting a tuple into list. Okay, or you are converting a tuple into set into tuples. Okay, so these are known as typecasting. So before typecasting, there's one more concept left, that is constructor. Okay. One second. So we have a concept of constructor, which means, let me show you. We have some few constructor like list, tuple, set, dictionary, and frozen set. Okay, let me show you. Okay, so suppose we have this list underscore one. That is, okay. So suppose we have this list of elements, and sorry, list of strings and numbers. Okay, so we have this list. Now we can create list by using another way. Okay, first way is by using square brackets. Means you are creating a list by using square brackets like this. So there is another way of creating a list, that is by using a constructor. You can mention here by using list constructor. Okay, so we can mention here list underscore two. Now here you have to call list here. Okay, list is a constructor here, a reserved keyword for Python. Then we can mention here square brackets, double brackets. Okay, then we can mention the elements. So we can mention any element, like we can mention integers, float, strings, or boolean values, etc. Okay, any number of values. Or we can insert any values. Okay, now this is a list. This is also a list. Okay, when we check, the type of list underscore two is type of list underscore two. Okay, that is this one. So if you run this, you can see this is a type of list. Okay, list underscore one is, we know that it is a list because we are using square brackets. But there's another way of creating a list. You can use a list constructor here. Okay, so list, your parentheses here and your elements here. Okay, and which type of value the list underscore two is storing, that is list. Okay, now if you print the list underscore two, so you can see this is a list. Okay, so here you can see this is a list. Okay, so we are writing using a list constructor, like we are creating a list using a list constructor. Now, and if you are printing this list underscore two, we have this list inside square brackets because it is a list. Okay, I hope this much is clear. Then next we have tuples. Okay, same as we have two ways of creating a tuple. First is using parentheses. Okay, and second is using tuple constructor. Okay, so here we can use tuple underscore two, and here you can use tuple here. Okay, as a constructor here, and you can create a tuple here like this. Okay, now if you print this, which is type of value, your tuple is storing this, that is, and secondly, your tuple itself, that is your tuple underscore two. If you run this, we will answer. So class tuple, and this is your tuple here. Okay, this one here, here's your tuple. So you can create your database by using this method, or you can create using this method. Okay. So next we have dictionaries. So dictionaries are like key value pairs. So first way is using curly braces, that is this one. Okay. Second way is by using dictionary constructor, that is dictionary underscore two, and your dictionary here. Then secondly, your values here, that is here. Let's say you are storing A1, comma B2, C3. Now, if you print this dictionary, when you check the type of variable value, it is dictionary underscore two. And if you are printing this dictionary underscore two, okay, so we are printing this dictionary. So here you can see this is a class dictionary. Okay, this one, and you can check the type of the syntax of dictionary. Okay, which is a specific syntax. You can see here we have a it is a key, and we have a value, key value, and key value. Okay, so this is how you can run a dictionary. So then we have set. So for the set, so there are two ways for creating a set. First, by using curly braces. Second, by using set constructor. Okay, that is set underscore second, set your parenthesis here. Okay, now we will run this print set underscore two, and we can check the type of value your set underscore two is storing. That is, we have to put type here. Okay, now we can run this. You can check. Is something wrong? Okay, just remove this comma here. Now here you can check. Okay, you have to use double parenthesis, I guess. Yeah, now we are good. Okay, here you can check. So this is a set. You can check your set is printed, okay, inside curly braces. Okay, and this is type of value is set. Okay, so you can create your set like this also, or you can create your set like this also. Okay, now we have frozen set. Frozen set is like which is used to make your set fully immutable in nature. So we have frozen set. So that is let's say we have this. Um, we have set underscore one. Okay, suppose we have a simple set of numbers. Okay, now we will convert the set into immutable form. Okay, that is by calling frozen set. So we can print frozen underscore set frozen underscore one. We will call frozen set here. Okay, set underscore one. Now, if you check the type of value your frozen set is storing. Okay, first we will like print frozen underscore one. Then we will check the type of value your frozen underscore one is storing. Okay, so here you can check frozen set. Okay, and we have type of value is frozen set. Class is frozen set. Okay, you can see frozen set, and your set here, and your class is frozen set. Okay, so this is how you can create your data types. Okay, in another way by using constructors. Now we have typecasting. That is like changing your one type of data type to another. Okay, so let's see. So first we have, let's say we have a list of elements. Okay, we have this elements. Okay, now we will convert your list into tuple. Okay, so this is your list. Now we will convert your list into tuple. That is known as typecasting, means changing a one data type to another. So we have this, let's say we have this tuple underscore one. So you have to put tuple and brackets and your list name. Okay, which you want to change. That is list underscore one. Okay, that is whichever you want to convert. Now, if you check the type of variable is tuple underscore one and type of value they are storing, that is tuple underscore one. Okay, when you run this, you can see we have now the class is tuple. Previously, list is a list. Okay, when you check the type of value list underscore one is storing, you can run this here. You can check. So this is a list. Okay, now we are converting your list into tuple. Okay, you can check. Now the class is tuple. Okay, we can mention the type here as well. Print type tuple underscore one. Sorry, list underscore one. We can run this. Now here you can check the class is list. Okay, that is this one list. Now we are converting a list into tuple. So we have this tuple here. Okay, class tuple. And we have the same list that is converted into tuple. You can check out. We have apple, apple, cherry, cherry, grapes, grapes, 1, 2, 3, 4, 5, like this, and true, true. Okay. So now your list is tuple here. Okay. No. So this is how you can change your list into tuple. Now we will see how we can change your list, convert your list into set. Okay. So we have this list underscore one. We have these elements here. Now we can check the type of value your list underscore one is storing. That is, of course, list only. Then we can print list underscore one. Now we will convert your list into set. That is set underscore one. We will call a set constructor here. Then we will name your variable. Okay, list underscore one. Then we will check the type of value your set underscore one is storing. And then we will print as it is. That is set underscore one. Now we can run this. Here you can check this out. First we have this list. Okay. Type of value you are storing is list. Okay, and this is like list. Now we are converting the list into set. That is this one. Now we have this class set and we have this set here. Okay. So set are unordered in nature. Okay, so order doesn't matter in your set. Okay, so they are unordered in nature. Order doesn't matter in your set. So that is why we have this order like 1, 2, 3, 4, 5 is first, and then we have these um strings. And when you run this again, we have this different order again. Okay, you can check 1, 2 grapes, 3, 4 apple, 5 cherry. Okay, so order doesn't matter in your set. That is why we have this set is in or it is unordered in nature. Okay, so this is unordered in nature. Basically, we have various like features of each data type. Okay, like set and unordered, they do not allow duplicates values. Okay, even dictionaries do not allow duplicates value. Okay, so we will discuss that later. Okay, like what are the features of these each and every data type. Okay, so this is how we can convert your list into set. Then we have convert your okay, so here you can check tuple underscore one. We have these values. Now we are checking the type of value they are storing. Print tuple underscore one. Okay. Now we will convert your tuple into set. That is set underscore one. We will call the constructor here tuple underscore one. Okay, and then we will check the type of value your set underscore one is storing, and then again we will print set underscore one. We can run this. Okay, see, we have this tuple. Okay, we have this elements of tuples. Now we converted your tuples into set. So now we have this set. Okay, now here we will convert your tuple into list. Okay, we haven't converted yet, right? List. Okay, so now we will convert your tuple into into list. That is, we have so here you can check it out. We have this tuple. Now we have converted your tuple into list. That is list. Okay, and here you can check the same tuple we have is converted into a list. That is apple, cherry, grapes, 1, 2, 3, 5, true. Okay, so this is how you can convert your one type of data type to another. Okay, now we will convert your set into list. Okay, so we will take 5 minutes break. Okay, so you can visit the JNtech website until. So in the meantime, you can visit the JNtech website. Okay, you can check out the course content of Python from here. Okay. Okay, so now we can start. Okay, so we can continue. So now we will see how we can convert your set into list. So we will create a set here, set underscore one. That is your set. Okay, any number of elements. Okay, now we will print the type of value your set underscore one is storing, and then we will print set underscore one. Okay, now we will see. Now we will convert it into list. List underscore one. That is your list here, and set underscore one you want to convert and print type of we can print the list itself, and then we can print the type of value your list underscore one is storing. Okay, now we can run this. So here you can check this is a set. Okay, and now we have converted your set into list. Okay, so this is your list. So this one is your set, and this one is your list. You can check each and every element is converted into list. Okay. So last we will see how we can convert your set into tuple. That is, we can call set underscore one. We can print type of value your set underscore one story. We can print set underscore one. Now we can check for we can create a tuple underscore one, a variable which will hold your value as a tuple. Okay, set underscore one, print that value your tuple underscore one is storing, and then your tuple itself. Okay, now we can run this. Okay, so this is a set, and your set is converted into tuple. Even you can convert your list set, or sorry, your list tuple your set into your frozen set. Okay, so you can easily convert your set, list, or tuple into frozen set. Okay, so this is all about typecasting. Now we will see the input function. Okay, so input function is used to take input from the user. Okay, so you are taking input from the user in the form of strings. Okay, so that is input. If you were to suppose if you are making any form, okay, so here you are, so there you are asking for the user to input their name. Okay, for that purpose we use input. So here we are asking the input from the user. We are asking some kind of value from the user. So for that purpose we use input function, which is used to take input from the user. Okay, now we will see, we will use input function here. So how to use it? Okay, here you can type, let's say you are asking for a name from the user. So name, your variable is equal to input. Then you can put here, enter your name. Print. Okay, so here input, enter your name and your name. So here you are printing, you are taking enter your name as a string. So this will print as it is. Okay, so enter your name will print as it is with this colon and with this colon and with this space as well. Okay, so when you run this, click on terminal, new terminal from here. Here type clear, type Python or file name. Your file name, there it is, first.py. Okay, this is another way of running a print of running any file, Python file. So enter the name. So let's say Bhavya. So Bhavya will print it as it is. Okay, so whatever you write inside a print, like input function, like enter your name, enter your age, whatever. So this will print as it is here. Okay, so enter your name, your colon, and your space here. Okay, so let's take another example. So it is asking for your name, that is Bhavya, and your last name, that is Jen. Okay, so this will print as it is. Your first name, your last name. Okay, now you can print it together like so your name, that is your name and your last name. Okay, so this will print as it is. Whatever the user will input, so this will print as an output inside your terminal. Okay, your first name, your last name. So, so now we can modify this statement like this. So we can add a string here. Your first name is okay, comma, your first name here. Sorry, your name here. Okay, that is name of your variable, comma. Then your last name is comma. So last name. Okay. So if you run this, so clear your screen. Now type it again. Now first name. See this one. So you can see your first name is Bhavya and your last name is Jen. So here you can check it out. So your first name is string here. Name is a variable. Okay, so whatever the user will input, so that will be stored inside your name variable. Same as we have your last name, that is a string, okay, which is printed as it is in your variable. So whatever the value inside your last name is, will be printed as it is. That is Jen. Okay, so you can try this. Now we can modify this more. We can create another program. Let's say your first name, input, enter your first name. Okay, let's remove this. Now age, input, so here you can check we have created a variable. We have created a variable that is first name and age. So we are as a programmer, we are asking from the user that enter your first name and your age. So let's say let's run this. We have this name. Let's say John. Age. 18. So you can see your first name is John and your last name is 18. Sorry, we can run this again. We have John here, we have 18 here, and your age is 18 here. Okay. Now, so let's perform some mathematical operations with the help of your input. Okay, so let's say num1 equal input. Here we are input enter the first number. Okay, num2, which is input, enter your enter the second number. Okay, so here we are asking from the user to enter number 1, number 2. Now we will add these numbers, num1 plus num2. So we will run this here. Number, let's say 10, 20. So we can notice here, instead of 30, we are getting 1020. Okay, why? So here we are adding number 1 plus number 2. So whatever the value inside number 1 is 10 and number 2 is 20. And we are here getting 1020. Okay, because here we are not adding the numbers, we are adding the strings here. So 10 is a character here, and 20 is a string here, basically a character here. And this process is known as, whenever you are adding two strings together, so this process is known as concatenation, which is like adding two strings together. So we can mention here concatenation, which is like adding two strings together. So here let's make a point to note that input function always, okay, that is always take numbers or take input in the form of strings. So whatever the user is putting, like whatever the user is inputting, so the input function always take input in the form of strings. So whether a user is putting a number, so it is also a string. Whether a user is putting any list or any stuff, a float number, a complex number of or integer number, so the input function will always take your input in the form of strings. That is why we have 1020, because we are adding two strings together. Here we are adding 10 plus 20. Okay, and as I said that any character inside quotations is not a number. Okay, it is not a number, it is a character here. Okay, 1020. So here we are adding two strings together. Okay, now we have to convert your strings into number, because input function always take your input in the form of strings. So what we can do is, now we can perform the typecasting, which is like converting your string into number. Okay, so we can see that. So before printing, we can remove this. Now we can use another variable, that is, now you can convert your number, your string into integers, or your float number. So we will convert in the form of integer. Number b equal int num2, print a plus b. Okay, now you can see we can run this here. Number 1, that is 10. Number 2, that is 20. Now you can see that we have 30 answer, because we have converted your strings into numbers. Okay, so these are the strings. String. Okay, now here we are converting your string into number. that is into integers. Okay, A and B are the integers here. Okay, so we are converting your strings value into integer. That is why we have 30 answer in place of 1020. Okay, so this is one way of converting. There is another way of converting, that is num1 equal. Suppose we are taking input from the user. Let me write this. First number, second input, enter second number. Okay, now we are adding print num1, okay, and plus num2. Okay, so let me remove this. Now here we can put integer here. Int input, same as int input here. Same as we can put here like this. And when you run this, one number, second number, let's say 20. So we have 21. Okay, so either you can do this in this way or you can do this in this way. Okay, so we always prefer this way. Okay, so integer and input your first number, your second number, or your addition here. Okay, now here you can convert your numbers into float also. Let's say float. Here you can put float here. Okay, so run this. My bad. Your number 20. So here you can check out, we have a answer in decimal numbers, that is in the floating point numbers. That is 30.0. So you can convert your strings into integers or float. Okay. So whenever you want to perform any mathematical operations, you can convert your strings from here only. Okay. Because input functions always take input in the form of strings. So we have to convert it into integers or numbers or float numbers. So we can copy this and we can paste it. Okay. So now let's take another example for this. Okay. So the last example, that is num1 int, then put input. Okay, then put your number, whatever you want to put. So enter your first number, num second, your second number, num3 int input, now we can print num1 plus num2 plus num3. Okay, so here we can run this. Num1, 2, 3. Okay, we are 36. Okay, so there's another way you can put these like operation inside any variable. Let's sum of all. You can put num1 plus num2 plus num3. And you can print sum of all. That is a variable name. Okay, one number. We can put any number. Okay, we have 51 as the answer here. Okay. So this is how you can use your input function. Okay. No. So then we have comments. One second. So we have comments. That is, so we have comments are ignored by the Python interpreter. Okay, that is known as comments. So basically, comments are used for note making. Okay, we can create notes. We can like put any statement inside your code. Okay, and we have types of comments. So we have single line comments and we have multi line comments. So we put single line comments with the help of hash. Okay, that is, this is a comment. Or multi line means you are putting it more than one line. That is using triple quotations. That is this one. So this is a, so this is a right. Okay, so we have multi-line and we have single line. So we can try this. So this is all, these all are comments here only. Okay, this is also comment. Basically, comments are ignored by your Python interpreter. Okay, suppose why we use comments for the note making. Suppose you are writing something or you are like coding for the first time. So you are writing print hello world. Okay, so here print is a function here. Now you want to write that like what is the function of the print. Okay, why we use print. So you can make a note here or make a comment here. That Python, sorry, print is a function which is used to display something. Okay, so here we are making a note. When you just removing this hash, so Python will throw you an error. The interpreter will throw an error because there's no meaning for this function here. Print here, here, is a reserved word. So if you want to write something, if you want to make a note of something, so that when you come back to your code after some time, so you can read this. So for this, we make a comment. So you can select, you can comment this. Okay, this is single line. Multi-line is like here we can put this and this. This is a comment. Okay, so this is how you can take comments. So in this code, in this file, we have everything is a comment here. You can see in green. So this is a comment. Okay, this is also comment now. And when you run this, we don't have any output because everything is ignored by the Python interpreter because this is a comment. This is all, these are all comments. Okay. Now there's a shortcut for the comments here. That is shortcut. That is for the comment or for uncomment. You can use control plus forward slash. Okay, and control. This is for comment. Control. This is for comment and uncomment. Same. Okay, same shortcut for this. In this is only for the VS Code. Okay. So suppose we have this line. Let's say it hello. Okay, now when you run this, we have output here. Okay, now select this, press Control plus forward slash here. Now this is a command, and when you run this, we don't have any output here. Okay, select uncomment, comment, uncomment like this. Okay, so this is a shortcut for this. Okay, whatever you want to comment, select and press Control plus forward slash. Okay, so Control plus forward slash to comment to uncomment. Okay, so these are all comments. If you want to uncomment, so press Control plus forward slash. Okay, now this is an uncomment. So we can comment this again. Okay, so that's it for today. Okay, so now rest we will continue tomorrow. So we will see tomorrow we will see the operators, control flows, and loops. Okay, so if you want to check out the course content of Python, then you can visit the JNtech website for that. Okay, so from here you can click Python. This column, so you can check out the course content of Python. Okay, you can check out the fee structure and the course duration. And if you have any inquiry, so you can call on this number, or you can mail, or you can WhatsApp from here. Okay. So feel free to ask anything. If you have any query, you can call on this number, or you can WhatsApp, or you can mail.